All right, so today we're going to solve systems of three equations using matrices. And so kind of what we've done so far, we've done what I call 2 by 2, two equations, two unknowns. We've done that by hand. We've done that as inequalities and equations, right? So we've also done, last time we've done 3 by 3, and you guys like realized how fun that can be, how frustrating, seriously. It can be pretty tough if you make a tiny error, things go wrong. Well, we can do this 2 by 2, 3 by 3. There's no upper limit to the number of equations and the number of variables, right? We could do a 10 by 10, but that would be awful by hand. And so if we go on in math, we learn another technique, and it's called matrices. And so if you are going to go on, we'll learn how to do this by hand. But we are going to use our technology, we're going to use our calculators to do this today. And so this will be pretty nice. So if you don't have a calculator, I need you to pause the video and get a calculator. Okay, so we're going to find the solutions to a system of 3 linear equations. This would work if it was 4 linear equations, 5 linear equations, 50 linear equations. Our calculator probably couldn't do it because it doesn't have the processing power, but other things can. Your computer could, all kinds of stuff. So if we have a system of 3 linear equations, and this only works if the equations are linear, so straight lines, doesn't work for quadratics, x squares, or anything like that. So here's what's going on. We're going to do a little rewriting of this thing, and we're going to do it a little bit differently than these notes say, because the way I do it is easier than the way the notes do it. So we're going to kind of skip this, and we're going to do something different. We're going to talk about it. Don't worry about this part right here. I don't care about that. So we're going to take, like look at example 1, we're going to take our system of equations, and we need to do some work to it. We need to rewrite it so that we can use our calculator to get an answer. And so the first thing we need to do is we need to make sure each linear equation is in standard form. It seems like we do that a lot, right? Put things in standard form. It must be kind of important. And then so A, B, C, and D are just numbers. And so A, B, and C are coefficients of the variables. And so we're going to take those coefficients and we're going to put them into a 3 by 3 matrix. And so this 3 by 3 matrix, all that talks about, all this really means, when we talk about matrix, this is the dimension of the matrix, and sometimes you'll see it referred to as DIM. But the dimensions of a matrix, we always calculate or figure out the dimensions of a matrix the same way. And so we're reading our rows times the columns. Row times column, or rows times columns, doesn't matter. So here's what we're going to do. We're going to come over and look right here. So this is our coefficient matrix. Whoops. So that's our coefficient matrix. That's a 3 by 3. So we're going to take those coefficients and we're just going to write them right here. Only the coefficients, right? So we have 3, -4, 2, 1. There's a 1 in front of that x. 5, -3, 5, 2, and 3. If I was missing, like say I didn't have this 2z right here, then instead of a 2, I would put a 0 right there. So you have to have that placeholder. So that's our coefficient matrix. And then we're going to take the variables, and we're going to write them in a 3 by 1 matrix. So this is our coefficient. And it's a 3 by 3. This is going to be our variable. And it's going to be a 3 by 1. And we're just taking our variables in the same order as they appear in our equation, right? Because the variables aren't always going to be x, y, and z. They could be other things. So we want to make sure that it's in the same order. X goes first. And then we bring down our y. And then our z. And so that's our variable matrix. The last thing that we have over here is what's called our solution matrix. And that is also going to be a 3 by 1 matrix. And so our solution is just whatever this thing is equal to. So we're going to bring those numbers down. I'm going to bring down 18, -15, and 20. So we've set this whole thing up. And then from there, we should probably write this up here, we're going to place the solutions. And so this would be matrix D down here into a 3x1 matrix, and then we're going to not do this, and we are not going to do that. So here's what we need to do. There's the way the notes tell us to put this in our calculator are kind of long and involved, and they're not easy to figure out. And so what we need to do is we're going to shortcut this, and I know a better way. So here's what we're going to do. I'm going to use this space right here. We have to rewrite our matrices. And so what we're going to do is we're going to take our coefficient matrix. So I'm going to take my coefficient matrix 3, -4, 2, 1, 5, -3, 5, 2, 3, and we're going to put a little bracket right there. Instead of a bracket on the other side, we're going to put a straight line. And so this is our coefficient matrix, and then we're going to write our solution matrix right here. We're going to write 18, -15, 20, and we're going to close that off. And so this would be our solution, right? Solution matrix. Now when we look at the dimensions of this combined matrix, this is 3 rows and 3 rows and 4 columns. So it's a 3x4. So we're going to grab our calculator and we're going to do a little work. To put this in your calculator, and the notes that you have right here are good, like this first step. Step 1, step 1, A through G, we're going to do all that. We are going to do this part differently. So part 2 is going to be different directions. So you can try and do this part 2 or not, but I have a much easier way to do this than doing all this business. So let's jump back up here. Okay. So let's grab our calculators. Here we go. So first off, we need to get to the matrix feature, which is this blue key right here. It says matrix. So we're going to go second. And this is the X inverse button, but we want to access the matrix. We need to edit our matrix. So we're going to scroll over and we're going to hit enter. From there, notice it says 1 times 1 or 1 by 1. This tells me that we have a 1 by 1 matrix, so I need to change this to a 3 by 4. I just hit 3, enter, 4. I hit enter, and notice my matrix is very different. And I'm going to enter this matrix over here. So we're going to enter 3, enter -4, enter 2, enter 18, 1, 5, -3, -15, 5, 2, 3. It is always a great idea once we enter these numbers into our calculator to double check them. So it looks like we have 18, -15, 20, 2, -3, 3, 4, 5, 2. Let's scroll over this way a little bit. 4, -4, 5, 2, 3, 1, 5. Okay, so we've double checked. We need to input our values in the matrix. If we didn't have like this 2z right here, that would have been a 0 instead of a 2. You have to have a placeholder for this to work. You can't leave one of these blank. Your calculator will give you an error. And so we need to get to our home screen, so we're going to go second mode to quit. And now here's where you're going to have to start writing some things down. Our directions are going to be different than they were on that sheet. And you can write them here, you can go down and write them on that sheet, it doesn't matter. We need to get back into our matrix operations here, so I'm going to go second matrix. And I want to go over to math. And so we're going to scroll down and scroll down and scroll down. That's kind of weird. And we're looking for RREF. And so what this stands for is reduced row echelon form. Right above it, notice it says REF. That is not what we want. If you do REF, you'll get the wrong answer and you'll never know. So we are looking for reduced row echelon form, and that is option B. So we're going to hit enter. We're getting the calculator ready. We're telling it what we want it to do, and we want it to find the reduced row echelon form. We hit enter. Now we could program all kinds of matrices in here, so we have to tell it what matrix we want it to do perform this operation on. So we go second, matrix. The only matrix we have programmed in is matrix A, so we're going to hit enter. You can close the parenthesis at that point or not, it doesn't matter. So we've told it what we want it to do, and we've told it what matrix we want it to perform the operation on. We have to hit enter and it'll do it. So we hit enter, and I want you to notice one thing. And it's kind of good, we have our equations over here, right? It looks like my x value is 1, so the coefficient on x is 1, and this is a 2. Now there's, on our second equation, our second row here, there's no x value, but it looks like we have a 1 for y, so that's a coefficient in front of y, and this is equal to -1. And then on our third row, we have a coefficient of 0 and a 0 for my x and my y. My z is 1, and this is 4. The way that we have set this up, what this has done is this tells me that x is 2, y is -1, and z is 4. So we're going to write that right here. So this is 2, -1, and 4. These are, so now this, with my variable matrix, is the solution to this system of equations. 2, -1, and 4, the solution to our system of equations.